This tutorial is designed to accompany Appendix D using Excel to solve enzyme kinetics problems. We are working on problem number 2. Our next task, having constructed the Lineweaver-Burke plot, is to determine the type of inhibition by inspection of the graph. In problem 1, we saw that we had two possibilities that were presented. One was competitive inhibition, in which the slopes were different, but the y-intercepts were the same. And that turned out to be the case for problem number 1. We were also presented with the possibility of uncompetitive inhibition, in which the y-intercepts were different, but the slopes were the same. In the problem presented here, neither the slopes nor the y-intercepts are the same. So there is another type of inhibition that is possible here, and that is called non-competitive inhibition, or sometimes mixed inhibition. There are 3 different possibilities of graph appearances that we can encounter with this type of inhibition. This figure shows 3 different types of non-competitive inhibition graphs with 3 different appearances. In the graph on the left, the 2 plots with and without inhibitor intersect above the x-axis. This indicates the inhibitor binds to the enzyme with greater affinity than to the enzyme substrate complex. In this case, when we calculate alpha and alpha primed, alpha will be greater than alpha primed, and our Km apparent will be greater than Km. In the center graph, the 2 plots with and without inhibitor intersect at the x-axis. This indicates that the inhibitor binds to the enzyme and to the enzyme substrate complex with equal affinity. In this case, alpha equals alpha primed, and Km with and without the inhibitor are the same. In the plot on the right, the 2 plots intersect below the x-axis. In this case, the inhibitor binds to the enzyme substrate complex with greater affinity than to the enzyme. In this case, alpha is less than alpha primed, and Km apparent is less than Km. Note for all 3 appearances that indicate non-competitive inhibition, this is a situation where the inhibitor is able to bind both to the enzyme and to the enzyme substrate complex. In problem number 1, we saw that competitive inhibition was illustrated, in which the inhibitor bound only to free enzyme. We haven't shown an example of uncompetitive inhibition, but in that case, the inhibitor binds only to the enzyme substrate complex. For non-competitive inhibition, the inhibitor binds both to the enzyme and to the enzyme substrate complex. And because of that, the inhibitor may or may not have a preference for how tightly it binds either to the enzyme or the enzyme substrate complex. In this example, in problem 2, we see that our plot has the appearance of the center graph in the figure just recently shown. In this case, the x-intercept is the same with and without an inhibitor. This is a situation in which the inhibitor binds both to the enzyme and to the enzyme substrate complex, but does so with equal affinity. In this case, the values of Km and Km apparent will be the same.